All right, so yeah, my talk is about basically enabling Azure AD authentication in Linux. So basically the agenda, I'm going to start with an introduction, and I'm going to do a quick little demo to show you what I've got working at the moment. Then I'm going to talk about the details behind what happens in that demo, including device enrollment, authentication, Windows Hello, which I recently have been working on, TGT retrieval for Azure Cloud and on-prem AD. And then if we have time, I'll do a little bit of hands-on, and we'll look at some of the MSAL library with some code examples. If you have any questions, you're welcome to ask them during the presentation. I may or may not see them in the chat if you post questions in the chat, so pipe up if you want to have a question answered. So I'm going to switch screen sharing. And I assume you now can see my virtual machine here. I've already configured this, but the configuration is pretty straightforward. In my Himmelblau project, you basically just set the authorized domains and users in the configuration file. Enrollment happens during authentication. So I'm going to show you what that looks like. Password authentication only has to happen the first time when you're enrolling. The authentication, the multi-factor authentication here is emulating the browser using GET and POST requests to Azure. And what you're not seeing in the background is it's currently enrolling the device. And now we set up a Windows Hello pin. And now the user is authenticated. If we lock the screen, you plug in the Hello pin and it unlocks. Take a look at NSS output. You can see, well, who am I sometimes doesn't work. I'm not sure why. But anyway, NSS is working. It's generating a UID and GID. There's the primary group is just matching the username, so it just creates a fake primary group with the same name as the username, and then it fetches the groups from Azure as well. Now, if I log out, I can log back in, and all I have to do is enter the Windows Hello key, and I authenticate. Now, the way that Windows Hello is working is that we've got a signed certificate from Microsoft associated with an RSA key in our TPM. And of course, this is a VM, so it's soft HSM. But we have that signed certificate with a RSA key, which now is authenticating us to Azure. And our authentication PIN is actually the authentication code to the TPM object. And that's how that works. And that's the same way it works in Windows.
I have a short question.
Okay.
Would it somehow be possible to do something like this also in a container so that the TPM is somehow emulated there?
I don't know. That is a good question. I mean, we for sure could use the soft TPM code. Yeah, I suppose that would work. I'm not sure. I haven't tested that.
Okay,
I think,
thanks.
yeah, it will work. You just need to be able to ensure that you bind mount whatever you use for this TPM. It's better to have it outside of the container and bind mount the access socket into it instead of having the whole soft HSM or whatever TPM on top of that is provided. But it's fragile. At
Okay.
least infra right now is a bit fragile there.
Okay,
All right.
thanks.
So Himmelblau is a project I've been working on for the past year. The concept is it's an interoperability suite for Azure AD, or Entra ID as it's called now. They rebranded a few months ago, and Intune. The purpose is to facilitate Linux authentication to Azure. I've got PAM and NSS modules. It's communicating through a daemon, and then the ultimate goal is to be able to enforce Intune MDM policies. So how does Himmelblau relate to Samba's Wimbind? And I've debated this for the past few months, and really I've decided that Himmelblau is just a staging ground for Windbind. And I intend for all of this to end up in Windbind. The core of Himmelblau is just a Rust crate I called MSOL. And all that Himmelblau really is, if you're familiar with William Brown's ConnieDM project, Himmelblau is ConnieDM with a thin wrapper over the MSOL crate. And so I want that MSOL crate integrated into Windbind as well. So, and yeah, given this is the future of Active Directory for Microsoft, this really is a space that Samba belongs in, and we need to be on top of this. The only holdup on Windbind integration is that Rust does not work in WAF, and I need help with that. There is a work in progress MR out there, merge request. If you take a look at, use that QR code there on the screen, it'll take you to my work in progress request. I really need some help to get Rust working in WAF, and then we can move forward with this. If you happen to be familiar with Ubuntu's AAD auth, it is intended to serve the same purpose, but I have some warnings for you. AAD auth does not enroll the device. It requires explicit client configuration in Azure Entra ID. Himmelblau instead is using the built-in Azure client the same way Windows does it. AAD auth does not perform MFA. In fact, it intentionally bypasses MFA. When Azure sends a demand for MFA, Ubuntu's AAD auth ignores it and allows the user in, which I think is a pretty serious flaw in their design. Their code does not use the TPM. It relies on a Microsoft library, which of course doesn't support device enrollment, etc., which is why they don't have it available. And also, their project appears to be abandoned. I've been following some of the discussions on the project page. There has been no significant work on it since last October. There have been no bug fixes, no feature fixes, and a lot of demands from people from users to fix things, and no response. I was collaborating with this team late last year, and they stopped responding. I've been trying to get a hold of them, and they are not responding to any messages. So my recommendation is don't use it. So the significance of this project, really, we're learning to understand. We're trying to come to understand some of Microsoft's proprietary technology. They've provided protocols for us to implement this. For example, the OAP XBC protocol explains how to write a broker. A DVRJ and DVRD explain how to enroll. And of course, there's the Kerberos protocols. There's MDE and MDE2, which document how how the Intune enrollment works. The problem is that these documents are all incorrect. I've worked with Microsoft's doc help. I've been chatting with them on and off. They've been reluctant to update these documents, and their argument is that the documents are really meant for on-prem Windows AD, which in my mind doesn't make much sense, because most of these documents are clearly tailored and written for the intended audience of Azure AD. In fact, there are explicit references to AAD throughout a number of the documents. So it's clear that they wrote these intending to provide documentation for Azure AD behavior, and at some point they abandoned that project and have stopped documenting things. I'm not sure the reason or purpose behind that. If Tom Devy's on, maybe he can explain it. He could certainly explain it better than me. I'm not sure if he's on here, but if so, feel free to pipe in. And anyway, the Microsoft is working on, or they're providing their own proprietary binaries, and that's their motivation, I guess, is they provide these proprietary Linux binaries to their customers. The proprietary binaries are lacking in some integration. They don't provide like PAM and NSS. They just provide some really basic integration with a local user. And of course, the open source community would prefer an open solution. All right, so let's get into some of the specifics. Let's talk about device enrollment and how that works. Now, you have to acquire a special token authorization token from Azure AD with special permissions in order to begin the enrollment. Then you generate a TPM bound set of keys. And then you need to do endpoint discovery to Azure AD to discover how to communicate with the APIs. And then, of course, you derive a transport key and so on. You send the authorization token, the certificate, a certificate request, and a transport key to the Azure DRS service, which you discovered in the discovery process. It validates that and writes a device object to Azure AD or Entra ID. And then the Azure DRS service responds with a certificate to the client, which then stores it. And finally, you do MDM enrollment, which I'll explain later. I haven't figured out how to do that yet. Not on Linux anyway. And there's some problems behind that, and that's why I haven't gotten that working. I ended up writing my own device enrollment specification because the DVRJ and DVRD specifications are so inaccurate. You can access that through the QR code there. So yeah, I wrote that due to a lack of accurate documentation from Microsoft. And the authentication token that you request, it has to request the enrollment that your enrollment URL is a resource, and it supports various authentication types. You don't have to use MFA. If you don't use MFA, your Windows Hello token will not have an MFA claim after enrollment. So obviously, we're going to want to prefer MFA be required. So as the part of the enrollment process, we create a primary RSA key known as the transport key. We create that in the TPM. It facilitates secure communication between the device and the Azure services that you're communicating with. And then you create a secondary RSA key in the TPM for generating a certificate signing request. That CSR is then sent to the DRS service, and you get back a certificate that's signed by Microsoft. The discovery service, now the discovery service responds with, I can't remember how many, like 30 services with their with the service versions and the resource IDs that you need to request and communicate with these services. The one we care about is the device join service. And this is what that response looks like. There are other responses from that discovery service that we need at later points, and I'll mention some of those. We send that a CSR that we generated in the enrollment request, and then that it'll include some basic information like the type of machine and the OS version, etc. This is what one of those looks like. So we have a CSR. I've truncated that, of course. You'll have your transport key. That's in a very specific format that Microsoft requires. You set your target domain, your device type, and we can specify that it is a Linux device, and it accepts that, and it recognizes that in the system. The join type is interesting. There's, I think, 5 different join types, and I don't really understand what all of them do, but they do show up differently in Azure depending on which join type you choose. I've determined that I think join type 4 or 8 are correct, but I don't know for certain because there's no documentation that explains it. In fact, the only documented join type is join type 6, which Azure rejects. And the documentation explicitly says that you must use join type 6, but it doesn't work. So we don't do that. This is what a response will look like. The certificate includes a thumbprint, which we don't really need. But then the raw body is just a big certificate blob that we need to save because we use that later during authentication. The rest of the data in the response, I'm not really sure what it's for. The SIDs that it lists are, I think they're the group memberships, but they've been mapped. It's the object IDs of the groups that have been mapped to SIDs is what those are. And then, as I mentioned, Intune enrollment is something I'm working on. It'll provide device management similar to group policy.
David?
Yeah.
Just a short question to the slide before.
Okay.
So the Azure server includes this local SID with the administrator SID, or what is this 544? I don't remember, but
I don't remember.
A built-in SID that's only valid to the local machine. So it's very unexpected that this comes from some outside authority other than the local machine.
Yeah, and the limited documentation that Microsoft provides explicitly says to ignore that. And that it's not something we can consume. I don't know why it's there.
Okay.
Other than it is there and it says don't use it. Yeah. It's unusual for sure. Okay, so Intune enrollment. It'll provide similar capabilities as group policy and AD, if you're familiar with that. It's kind of what got me interested in this, is that I was working on group policy before. So I'm working on it. I know how client enrollment works for Windows. That's pretty clearly defined. There's documentation for that. That's actually accurate, surprisingly enough. And you can view that behavior on a Windows client. It works exactly as expected. The problem I'm encountering is that Linux Intune enrollment is a thing. It's very specific. Windows Intune enrollment is completely different. And you cannot specify that you're enrolling a Linux machine using the Windows client enrollment process. It doesn't work. And the API for communicating with the Linux enrollment process utilizes JSON, and the Windows enrollment uses SOAP. I don't know why. This is what a Windows enrollment looks like. I just wanted to show you the big ugly blob. Yeah, there's a lot going on there. It's a SOAP request. It's very specifically defined. Somewhere in there, you'll see device type says CIM client _ Windows. And you have two options in that field. It must be either client Windows or client Windows Phone. And they're still supporting Windows Phone enrollment here, but nothing else. That's what the documentation says. There doesn't appear to be any other value that is supported. I suppose I could fuzz it and try to get it to respond and see if there's anything else that it allows, but I haven't tried that yet. The response responds with a with this SOAP blob, as you can see. When I've tried to investigate Intune enrollment, Microsoft, as I mentioned before, does provide Linux binaries. And so I tried to observe their behavior. I could see from the debug output from the binary that they're contacting a specific endpoint. I found that I could query that endpoint by calling a specific, find the endpoint by calling a discovery request that's sent to Microsoft's deprecated API, ironically, and it gives me the same endpoint. But when I try to talk to that endpoint, it's responding in JSON. So it appears to be expecting a JSON input, and I don't know what the input is or what is it's expecting. Okay. On to authentication, the differences, the similarities between Azure AD, enrolled device and not enrolled. So first off, MFA authentication, you've got to, we only authenticate with MFA the first time when we're enrolling. So here's the basic layout. We're going to send an we'll start with sending a single factor authentication request with a password. Azure will then respond and say if you need to supply MFA, and then you start an MFA response, and then you sit and you poll and wait for a response from Azure, and then well, actually you're waiting for a response from the human technically. Once it's authorized, then Azure will respond with success, and your client will get a authentication token. So there are a few differences in how the initial authentication is performed. Microsoft expects, it expects an authentication via browser window, while Linux, obviously, we expect authentication to go through PAM prompts. That's kind of tricky. So what I'm doing right now is emulating the browser behavior through web requests, post and get. This isn't the safest way to do it, but it's working. Alexander, you've talked before about providing a browser authentication. We really need to provide a browser in GDM, and that's the long and short of it. It's ugly, but somehow we need to enable that. But for the time being, this works. An alternative.
So we actually have some progress. Some progress on that. The canonical people worked on embedding the browser view into the GNOME shell.
Okay.
So there is something like that. And there's a preliminary discussion with GDM developers that they can make a mode that effectively runs a separate GNOME session where this browser could be done, and then the view from it is bleeded back into the actual GDM view. So we are working on that together. It's not fully in place, but what we have already is a QR code displayed on the GDM login page. That is working, and this will be in GNOME 46, 47, I think the next one, effectively. So this will enable at least a bit better kind of transition to your phone, for example, to complete this operation. But we can get this.
Yeah, and you can see my next comment here is that I'm using DAG, so device authentication or authorization, exactly as you're saying. I haven't integrated with that QR code stuff that you guys have worked on, but I'm aware of it. I'm going to add that to my project once it's in the GDM login. But that's awesome work. And yeah, once we have the browser, that's the ideal, so that we can provide the same experience that a Windows user would expect. And that, of course, is only necessary for the very first login.
Let me just add a bit here. So as a part of that work, there is a common interface in GDM to communicate with PAM modules using JSON payload. So you can add that JSON payload support to your PAM module, and it will work similarly how PAM SSS works with it now. So we'll be just reusing the same front end on the GDM side.
Yeah, I saw that. That's awesome work.
So one question. So on Windows, all this only works if you have the graphical interface installed.
Yep.
Because some servers don't have a GUI, and then all this doesn't work.
Yep. And on Linux, or at least in my implementation, I've got this. You saw it was all happening through PAM, and so having that PAM interaction means that for example, we could do this from the command line. We don't need a GUI interface. Although I noticed it doesn't work through SSH. For some reason, SSH is not forwarding all of the PAM prompts. I think that's a bug. Because I'm sending multiple PAM prompts. I mean, you saw the interaction. It's like 5 PAM interactions for a single authentication, but that's because it's doing the enrollment at the initial authentication. So we'll need to look into that, but it should work on a non-GUI terminal. And I think that's an important thing to have implemented in WinBind is that we provide non-GUI enrollment.
I got disconnected somehow, but I wanted to say that there is a SSH configuration option that you need to enable in order to get the PAM prompts going through.
Okay. Well, thanks for that. That's important.
Yeah,
I'll chat with you after later.
I think I have documented this in IPA design pages, so you can look at there.
Okay. So the MFA enrollment, that whole song and dance is really only required once, because once you're enrolled, you can use your Windows Hello token. I won't go through all of the points on this slide, but one important thing, the enrollment authentication token that you get is very interesting. It has interesting privileges. It allows you to exchange it for higher privilege things such as an Intune enrollment token, and actually you exchange it for a DRS service token so that you can enroll. So it's an enrollment token, but you have to exchange it to enroll into DRS service, into Intune service. And then once you're enrolled, you can exchange it again for a primary refresh token, PRT. And also you can exchange it to enroll a Windows Hello token, which is important for our enrollment process. This is a PRT. A PRT is a master refresh token, which allows users to access resources securely without repeatedly entering credentials. So we can store this in a cache, and basically we can infinitely kick this can down the road and always be authenticated as this user. I'm not really doing that right now in my project. I'm not really sure the implications or how we would want to use this, but we can potentially remain authenticated indefinitely as this user. And notice, importantly, down at the bottom, that there are TGTs in that primary refresh token, which we can infinitely kick down the road and continue and refresh over and over again. There is a limited time window when this particular token expires, but you can refresh it before it expires, and then you've kicked it further down the road, and you've got new TGTs, etc. To request a primary refresh token is a different song and dance. You send your user credentials, etc. You have to build a special JWT request, which you send to Entra ID. You can only do this if you are an enrolled client device. So if you have authenticated to an enrolled device, you can request a primary refresh token. Let's talk. Yeah.
One question again. All these tokens which are also stored in the TPM later, are they for the machine or for a single user?
Both. So the transport key and this and the key that's associated with the certificate that you requested are for the device. Well, okay, so I guess the ones that we've talked about so far are just for the device, and they're for multiple users. What I'm about to talk about with Windows Hello authentication, you'll create yet another TPM key that is explicit to a specific user. Does that make sense?
So in the example you did, where you just entered the TPN pin, that pin was global per machine and not for the user?
No, that's user specific. I mean, it's associated with a machine key, but the user has to unlock it using that pin, and only that user presumably would know the pin. But the other two TPM keys are global and are used for every authenticating user.
And they don't have a pin, or
they'll also have individual pins. So every user who signs in will create their own Hello pin, and they'll have different pins which are associated with that device.
Okay.
So now let's talk a little bit about Windows Hello and how that works. Here's just a diagram of how it's working in Himmelblau right now. You use the discovery service again because the discovery service responds with a key provisioning service. And then you create a hello RSA key in the TPM. Can you hear me?
Yes.
All right. Sorry about that. There we go. Yeah, I got kicked out. I tried coming back in through Chrome and it crashed over and over again. So I just came back in through Firefox. So that was interesting. Anyway, I'm back. Yeah, so to authenticate using Windows Hello, we sign a JWT request and send it to, we sign it using the TPM and send it to the assertion to Azure, and it authenticates us and sends us a PRT, etc. Let me get back to where I was. There we go. I saw the camera light turn off on my camera. That's how I knew I had lost the connection.
So, David, the PRT is kind of like a trust this device sort of a thing.
Yeah.
And then you have to log in too, but okay.
Yeah, once you have a PRT, that's the thing you can kind of kick down the road and keep renewing, and cache it or whatever. But and you can exchange the PRT for an authentication token to any service.
But it's not fungible. You need the local TPM and stuff like that to use.
Yeah, you can't. It's not, the PRT is useless outside of the device that it's enrolled on. As long as you've properly secured your secrets in the TPM, it can't be moved to another device and used elsewhere. It's secure.
Cool. That's a surprise to me, the fact that it exists. Okay.
Oh, okay. Yeah. All right. That's what the key provisioning service or a discovery looks like. I mentioned that earlier. So yeah, I kind of went over these details already. Enrolling a Windows Hello key. We end up getting back this JSON blob with this, or we construct a JSON request with this KNGC key. It's this complex request. You can look at the source code if you want to understand how that's working. Yeah. Okay, so let's talk about the TGT that shows up in the PRT. That's kind of a cool little thing. And it has two PRTs, or two TGTs in the PRT. It has a on-prem, if configured, for a on-prem AD that's syncing with Azure AD, and then it also has a cloud TGT for communicating with cloud services like SMB in Azure. I haven't implemented this or utilized any of this yet. This is what the structure basically looks like. And here's an actual readout from one. I dumped this yesterday, communicating with Azure. You get this message buffer blob, and if you base 64 decode that, it appears to just be a TGT. No surprise there. It looks like it's just a raw TGT that's dumped into a buffer and sent to us, which is convenient. Now the question is, what do we do with that? I don't know of any way to import that TGT in the cred cache. I don't think there's a way to do that right now. So we need to figure out a way to do that. If anyone has any suggestions on how to force that into the cred cache, then I'm open to suggestions.
You can construct one. The structure of cred cache, a file-based, is well known, so you can construct one.
Okay.
And because this is TGT, you effectively starting with a new cred cache.
Yeah. Good point. Okay, so what's next for the project? Most of this stuff is going to happen in the library that's going to be integrated in Winbind. So Windows Hello with biometrics is something I want to get working. I'd like to have the fingerprint reader working. I don't have that yet. Right now, I just have implemented a PIN. That just is really what we need is the fingerprint reader to unlock a TPM key, and then we can use that. I don't want to do facial recognition. That's kind of a hairy, a big project. I talked about GDM browser sign in. Alexander mentioned, yeah, they've been working on this. I want to get Intune enrollment working and policy application. I'm going to use Augius for that. Again, Winbind integration. I need help with WAF. WAF is ugly. I'm sorry, it's ugly. I need to figure out proper ID mapping. Right now, I'm doing something a little weird. I talked about this briefly yesterday during Alexander's project or talk. To do ID mapping, I'm taking the RID of the converted object ID of the user, convert it to a SID and take the RID off of it. And that doesn't really work because that RID isn't guaranteed to be unique in the domain because it's really just the random bits off of the end of a random GUID, and that's not really safe. Unlike in AD where we're guaranteed that RID is going to be unique, in Azure AD we don't know what it is. And then the last thing that I really want to do on my back burner is browser single sign-on. So there's this project called XDG Credentials Portal, which integrates WebAuthn. It provides a platform API for Firefox and Chrome and such on Linux, and that would allow us to integrate with the TPM, and then we can have single sign-on where you log in using your Azure ID, Windows Hello login, and then you're just logged into Teams automatically, etc. I think I'm basically out of time, but there was one last demo I was going to do. Stefan, you have a question?
Yes, regarding the single sign-on bit. So what I'm dreaming about is so actually with SSH agent, there's an option to specify the -c option so that each time the SSH key is used, you get a prompt in order and confirm it before it's used. And if the single sign-on thing could have something like that, so that each authentication is act by the user interactively, that would be great, because all this other magic single sign-on doing something not expected by the user seems to be a bit dangerous.
That's, I think, a purpose of the portals, at least in GNOME environment. And that's what people moving into exposing resources like this through the portals API. And at least these Flatpak based applications are using it, and also Firefox and other browsers. So the portals is a way of triggering access to resource, and then portal implements how it would ask users. So for example, I think Pipewire is implemented access to your audio and streaming part using Portal. So it always asks you whether you like to share mic with the browser, or share your screen or your camera. It should be done similar way.
Yeah.
So I was just trying to run through my demo really quick so you could see it. Just to show you the capabilities using this simple module, I just requested a authentication access token using my little MSOL cargo crate, and you can see what the response looks like. Yeah, this is actually the response after enrolling, and so I have a PRT that's attached, big ugly encrypted blob. I'm encrypting the PRT, and it's never exposed outside of the module, just for security reasons. And then provision a hello key. I dumped that. You don't usually do that. Normally it's not going to debug like this. I'm just dumping it for sake of a demo. And then you can acquire a token, get a PRT here as well. The TGTs are enclosed inside of this encrypted PRT, which normally is not exposed, but I went ahead and dumped those as well out of the PRT just to see what they look like. I don't have on-prem TGTs enabled, but that's what that looks like. And the source code is here. This MSOL crate using the broker client application. Yeah, I was going to go into more depth on that, but we're out of time. So.